Further examples on lowest common multiples, LCM of numbers. We are taking our examples from page 67 of our book, Hidden Fact in First School Living Skill Mathematics and Quantitative Tests. Our first example, find the LCM of 3, 6, and 9. The options are given: A, 3, B, 9, C, 18, D, 54, E, 60. Solution. We rule our line, then we impute the numbers 3, 6, and 9 carefully. Then we start dividing by a prime factor. We started from the lowest one, which is 2. 2 divide 3, cannot. We bring the 3 down. 2 divide 6, 3. 2 divide 9, cannot. Without remainder, we bring 9 down. Next, we can conveniently pick 3. 3 divide 3, 1. 3 divide 3, 1. And 3 divide 9, 3. We can go with 3 again. 3 can still divide. 3 divide 1, you bring the 1 down. 3 divide 1, you bring the out 1 down. 3 divide 3, give you 1. Since we have achieved a clear result of 1, 1, 1, we can now say that LCM of 3, 6, and 9 is equals to 2 times 3 times 3. That is 2 times 3 raised to power 2 in index form. And our value is equals to 18. Another example. Find the LCM of 18, 27, and 36. The options are given: A, 3, B, 9, C, 27, D, 54, E, 108. Solution. Let's rule our lines as usual. I will impute the numbers. We're talking about LCM of 18, 27, and 36. We impute the numbers 18, 27, 36. When we look at it carefully, remember prime factor should not be out of your mind when dealing with LCM and HCF. So the lowest prime factor there is 2. Take 2. 2 divide 18 will give you 9. 2 cannot divide 27, so we'll bring it down without remainder. So we'll bring it down. 2 divide 36, 18. We look at the resultant value. 2 can still divide one of the numbers there. So we're free to go with 2. 2 divide 9, we'll bring it 9 down. 2 divide 27, cannot bring it down. 2 divide 18, give you 9. After that, the next lowest factor, prime factor, is 3. As regard to the problem we have at hand. 3 divide 9 will give you 3. 3 divide 27 will give you 9. 3 divide 9 again will give you 3. We can still go with 3 to divide through. 3 divide 3 give you 1. 3 divide 9 give you 3. 3 divide 3, 1. We can still go with 3. 3 divide 1, you bring the 1 down. 3 divide 3, 1. 3 divide 1, you just bring the 1 down. That is a method of our operation. So LCM, we can conveniently say LCM of 18, 27, and 36 is equals to 2 times 2 times 3 times 3 times 3. That is, in index form, 2 raised to power 2 times 3 raised to power 3. Our resultant value is equals to 108. Another example. Express the LCM of 20, 18, and 15 in index form. A, 2 raised to power 2 times 2 raised to power 2 times 2 raised to power 2 times 5. B, 2 raised to power 2 times 3 raised to power 2 times 3 raised to power 2 times 5. C, 2 raised to power 2 times 2 raised to power 2 times 5 times 5. D, 2 raised to power 2 times 3 raised to power 2 times 5. E of 2 raised to power 2 times 3 raised to power 2 times 3 raised to power 2 times 5. Solution. Let's rule our little table. We're looking for the LCM of 20, 18, and 15. The lowest common prime factor we can divide is 2, starting with 2. 2 divide 20, you get 10. 2 divide 18, the result is 9. 2 divide 15 cannot, so we'll bring the 15 down. We can pick 2 again from our horizontal value to divide. 2 divide 10, give you 5. 2 divide 9 without remainder, cannot, so we'll bring it down. 2 divide 15 without remainder, cannot, so we'll bring it down. Now we can conveniently pick the next prime factor there, which is 3. 3 divide 5, cannot, you bring 5 down. 3 divide 9, you get 3. 3 divide 15, you get 5. Let's finish up with 3 since there is still 3 there that we can divide. So pick 3 again. 3 divide 5, cannot, without remainder, we'll bring it down. 3 divide 3, 1. 3 divide 5, cannot, you bring it down. The next number we pick to divide through is 5. It's obvious. So 5 divide 5, 1. 5 divide 1, you just bring the 1 down. 5 divide 5, 1. We have conclusively say LCM of 20, 18, and 15 is equals to 2 times 2 times 3 times 3 times 5, which is equals to, remember our answer is supposed to be in index form, 2 raised to power 2 times 3 raised to power 2 times 5 in index form. That is what we are required to present our answer with. Another example. Find the LCM of 105 and 120. Solution. We rule our lines. We are to find the LCM of 105 and 120. We impute our numbers, 105 and 120. When you look at the numbers, the prime factor that can go here, 2. Divide 105 cannot. Then 120. 2 divide 120 will give you 60. We can still make do with 2 here again. 2 will bring down the 105. Then 2 divide 60 without remainder, you get 30. We can still make do with 2 as a common factor. 2 divide 105, you bring the 105 down. 2 divide 30, you get 15. The next number that can go conveniently is 3. So we are starting gradually. 3 divide 105, you get 35. 3 divide 15, you get 5. Next, we take 5. You can see how we are proceeding gradually. 5 divide 35, you get 7. 5 divide 5, you get 1. Next, we take 7. 7 divide 7, you get 1. You just bring the other one down. Conveniently, we can say LCM of 105 and 120 is equals to 2 times 2 times 2 times 3 times 5 times 7. That is 2 raised to power 3 times 3 times 5 times 7 in index form. Another example. Find the LCM of 7, 13, and 49. The options are given. A, 627. B, 637. C, 649. D, 757. E, 847. Solution. We rule our line as usual. We say LCM of 7, 13, and 49. We are looking at prime factors here, the numbers that can divide through the given numbers. If you look at the given value critically, you see that 2 cannot divide here, 3 cannot go, neither 5. The first number, smallest number to start with here is 7. So 7 divide 7, 1. 7 divide 13, you bring the 13 down, since you cannot go without a remainder. 7 divide 49, 7. We can still apply 7 again. You just bring the 1 down, divide 1, you bring the 1 down. 7 divide 13, without remainder you cannot, so you bring the 13 down. 7 divide 7, you get 1. Next, we take 13. 13, bring the 1 down. 13 divide 13, 1. So you bring the other 1 down. So the LCM of 7, 13, and 49 is equals to 7 times 7 times 13, which is equals to 637. Another example. What is the smallest number which has 6, 8, and 12 as factors? A, 24. B, 26. C, 36. D 48, E 72. Solution. We are simply asked to find the LCM of 6, 8, and 12. Let's rule our lines and we impute our numbers 6, 8, and 12. Now, starting from the smallest prime factor that can go in there, 2. 2 divide 6 will give you 3. 2 divide 8 will give you 4. 2 divide 12 will give you 6. We can still apply 2. 2 divide 3, you bring the 3 down. Now 2 divide 4, 2. 2 divide 6, give you 3. So we are just with the smallest number, we don't move. That's the best way. So we still apply 2. 2 divide 3, we bring 3 down. That remainder cannot. Then 2 divide 2, bring 1 down. That is 1. 2 divide 3, cannot. You bring it down. 3. Next, we can apply 3 to divide 2. 3 divide 3, 1. 3 divide 1, you bring the 1 down. 3 divide 3, 1. Bring the 1 down. LCM of 6, 8, and 12 is equals to 2 times 2 times 2 times 3, which is equals to 24. Another example. Express the LCM of 8, 12, and 30 in prime factors. A, 2. B, 2 times 2 times 2 times 2. C, 2 times 2 times 3. D, 2 times 3 times 5. E, 2 times 2 times 2 times 3 times 5. Solution. We impute our tables at LCM of 8, 12, and 30. Impute our values 8, 12, 30. Starting from the smallest prime factor. So we take 2. 2 divide 8, 4. 2 divide 12, 6. 2 divide 30, 15. We can still take 2 again. 2 divide 4, 2. 2 divide 6, 3. 2 divide 15 without a remainder cannot. You bring the 15 down. You can still take 2. 2 divide 2, 1. 2 divide 3 without a remainder cannot. You bring it down. 2 divide 15 without a remainder cannot. You bring it down. Next, we can conveniently take 3. 3 divide 1, you bring the 1 down. 3 divide 3, 1. 3 divide 15, 5. Next, we are left with 5. 5 divide 1, you bring the 1 down. 5 divide 1, you bring the 1 down. 5 divide 5 is 1. So LCM of 8, 12, and 30 is equals to 2 times 2 times 2 times 3 times 5. Another example. Find the LCM of 2 raised to power 3 times 3 raised to power 3 times 5 and 2 raised to power 2 times 3 raised to power 3 times 5 raised to power 2 times 7. Options are given. A, 2 raised to power 5 times 3 raised to power 5 times 5 raised to power 3 times 7. Option B, 2 raised to power 3 times 3 raised to power 3 times 5 raised to power 2 times 7. Option C, 2 raised to power 2 times 3 raised to power 3 times 5 times 7. Option D, 2 times 3 raised to power 3 times 5 raised to power 2 times 7. Option E, 2 times 3 times 5 times 7. Solution. A good knowledge of LCM is required here. We arrange our first value 2 raised to power 3 times 3 raised to power 3 times 5. Under each of the value, we put the second value. 2 will be under 2, 3 will be under 3, and 5 will be under 5, like that. So 2 raised to power 2 times 3 raised to power 3 times 5 raised to power 2 times 7. Now, the highest power in each figure is to be taken from each of the base numbers. What do we mean by this? When you look at 2 in the first given value and 2 in the second given value, we are not talking about their powers. We are talking about the base numbers. In the first given value, 2 is raised to power 3. In the second given value is 2 raised to power 2. So the highest power of 2 in the first case and the second case is 3. So we take 2 raised to power 3 times, when we look at 3, the power of 3 in the first value is 3. Second value is 3. So the power of 3 are the same. So we take 3 raised to power 3. When we look at 5, in the first value, the power of 5 is 1. In the second value, power of 5 is 2. So we take the highest power there, which is 2. 5 raised to power 2 times, of course, we bring our 7 down. That is our answer. Another method, we rule our line, then we start imputing the values. First set of value, 2 raised to power 3 times 3 raised to power 3 times 5. The second set of value, 2 raised to power 2 times 3 raised to power 3 times 5 raised to power 2 times 7. Now, when you look at the base number, 2, 3, 5, 7, those are the base number given. And these are also prime factors. So we start with the smallest, which is 2. Taking 2 divide the first set of value. When you divide through, you look at the power of 2, which is 3, that will now reduce to 2. So we now have 2 square times 3 cube, 3 raised to power 3 times 5. You just bring down the other value as it were. In the second value, the power of 2 is raised to power 2, so it will be reduced to 1, power 1. But we will not show the 1 there, so we just write 2 times 3 cube, we bring down the other value, times 5 squared times 7. We can still proceed with dividing through with 2. 2 in the first value, resultant value, 2 raised to power 2 will now reduce to 2 raised to power 1, but we're not showing the 1, so we just write 2 times 3 cube times 5. In our second value, 2 raised to power 1, though the 1 is not showing, so it's 2. Now 2 divide 2 will give you 1. So we just say, we put it down 1 times 3 raised to power 3 times 5 squared times 7. If you look at our resultant value, 2 can still apply here. So 2 divided 2, you now get 1. In the first value, 1 times 3 cube, every other value will remain the same. So in this second value, you just bring down our value, 1 times 3 cube times 5 squared times 7. Yes, next, if you look at the common factor that we can use next after 2 is 3. So 3 divide our first set of value. The power of 3 from 3 will now reduce to 2. So it will now be from cube, it will reduce to square. So we now have 1 times 3 squared times 5. Now, similarly, in the second set of value, from cube, it will reduce to square. 1 times 3 squared times 5 squared times 7. We can still pick 3 again. 3 going through, you now have 1 times 3. The square will reduce to power 1, but we're not showing the 1, power 1. So we just write 3 down times 5. Then also, similarly, in the second set of value, 3 square will now reduce to 3 raised to power 1, but the power 1 will not be shown there, so we'll just write down 3. We now have 1 times 3 times 5 square times 7. 3 can still be applied to divide through. We now have 1 times 1 times 5, and then also 1 times 5 square times 7. If you look at the resultant value, 3 is out of the game. The next number is 5, smallest number. Right? So 5 we divide in our first set of value. 5 we divide 5 will give you 1. So that's why we have 1 times 1 times 1. In the second case, you have 5 square will now be reduced to ordinary 5 because 5 raised to power 1. So we just write the 5 down and bring down our 7. We are not yet through with 5, so we can still take 5 again. 5 will just bring down 1 times 1 times 1, and it will now 5 divide 5 will give you 1. So that's why we now have 1 times 1 times 1 times 7. And with our 7 left, that is the next value to divide through, next prime factor to use to divide. So we take 7. 7, you just bring down 1 times 1 times 1. Then you bring down 7 divided 7 will give you 1. So we have our result 1 times 1 times 1. Since we have attained uniform 1, we can now give our LCM is equals to 2 times 2 times 2 times 3 times 3 times 3 times 5 times 5 times 7. That is the same as equals to 2 raised to power 3, that's 3 cube, times 3 cube, times 5 square, times 7. But this is our last example on LCM of numbers. We have some exercises from our book, Hidden Fact in First School Living Certificate, page 68. The examples are given. You can look out for their solution at the answers at the back of the book, either the hard copy or the soft copy. Thank you.